of the top scientists in the recent global ranking scientist list. And he is an elected fellow of National Institute of Ecology and Indian Association of Hydrologists, Institution of Engineers and Institution of Electrical Engineers, and so many more such professional societies. He has guided many students for master's and doctorate degrees, and it's a great honor, sir, to have you here. And over to you, sir.
Okay, thank you, Dr. Anandi. Now I will share the slides. Okay, slides are visible now.
Yes, sir.
Yes, sir. Yes, sir.
Okay, so today I will talk about how we have used the science and technology to ensure the sustainability of natural resources. You know, when we talk about the application of science and technology, we do the society relevant research. Now, our agenda is to make sure that our next generation has a clean air, water, and environment. For that, we need to ensure the sustenance of natural resources and with minimal disasters. And when we have that, there will be security, survival, and peace. You know, what happened in the Jammu yesterday, that should not happen in any part of the country. You know, those are the signs of the imbalance in the nature. Now, when we look at when we design our product based on the principles of nature, we are also minimizing the burden to the nature. For example, if you look at this slide, it talks about the simple food chain. When you look at the simple food chain, there is an energy and material transfer happens when we consume some item. You know, the plants produce food, it is eaten by the next level of organism. Then whatever is left in the system is converted into elemental form by bacteria and fungi. That means when you look at the nature, there is nothing called waste. Now, based on this principle, if you design solid waste management system, probably you will be doing the wonderful job. So that means the message here is there is no waste in the ecosystem, and the waste happens when people misuse or mismanage the ecosystem. Now, let's look at what is the kind of the diversity of life that exists on the earth. We have about 8 to 12 million species as per the scriptures, and as per the science, we have estimated about 1 to 1.3 million species. Now, my work, if you look at, we have done extensive research in the Western Ghats. My study area extends from Kerala to Gujarat, which is about starts at 8 degree latitude to 22 degree latitude. And when you look at the total area of the Western Ghats, it constitutes only the 5% of the India's geographical area. But that region, if you look at the number of species that occur in the region, you see that as we move latitudinally, you see at 8 to 14 degree latitude, you have the highest number of species. The highest number of species means the diversity of plants and animals. When you have diversity of plants and animals, you have diverse food and diverse medicine. Apart from that, this region, perennial river, you have the water in the peninsular India. That means this region provides us the food as well as the water and the medicine. Now we need to manage this ecosystem. So this ecosystem management, we can manage it provided we have the understanding of the ecosystem process. That is where when we manage it, we should make sure that physical and chemical integrity of the ecosystem is maintained. Then only you can have the biological integrity. That means the species that occur in a particular region can occur in that location, provided we do not disturb the physical the integrity, and also we do not pollute the ecosystem there. This kind of management is called ecosystem approach. See, when we look at the Western Ghats with the diversity of plant, it also they have the sequester the carbon. As you all know, the warming of the earth has happened because of the increase in carbon species in the environment. That means the Western Ghats also helps in mitigating the climate in the environment. Now, when we talk about this kind of planning, we need a data. So fortunately, we have a big data. When you look at the remote sensing data, we have the multi-resolution data from 1970 onwards, every 21 or 30 days interval. And this is the data which helps in understanding the patterns and the spatial temporal pattern in the region. So which helps in taking the appropriate decision. Now, when we use such data, we also use the collateral data like the Survey of India topographic map, then the high resolution data. And also we go to the field and collect the data using the GPS, which provides the which helps us in collecting the location specific data. And of course, we use the online virtual data, what is available in the form of Google Earth or Bhuvan. But when you look at this remote sensing data, finally it is the collection of number. The understanding the kind of the patterns in this number, we try to classify the land use categories or land cover categories in the region. Now, when you look at the power of this data, we have the huge the number of data from 1973 onwards, and that big data you can analyze it using the machine learning algorithms. There are the well-established machine learning algorithms like random forest, or the support vector machines, or the simple the maximum likelihood classifiers, or you can also try to find out the pattern through the unsupervised classifiers also. So that means the latest technologies of the data handling, whether it is artificial intelligence, machine learning, and deep learning operators, you can use to handle this spatial data. Now, we also, because the large quantity of data is available, we can also predict what is likely to happen from 10 years or 20 years from now. So that is what is the visualization. We do that, which helps in understanding the likely implication of the decision. So that's what we have done. And when I present the case study, probably it becomes clearer. That means when we acquire the data, we go to the field, collect the data, and then do the remote sensing data classification. Then finally we interpret the data. Now, this is what we have done for the Western Ghats. See, as I said earlier, Western Ghats extend from Kerala to Karnataka. Now we have looked at what is the land cover change that has happened in the region from 1985 to 2018. If you look at, there is an overall 5% decline in the forest cover. And also, not only the forests have declined, the forests are also getting fragmented. This is we have done by computing PF and PFF. These are the metrics we use to assess the level of fragmentation in the system. Now, we also assess what is the amount of the carbon that is stored in the trees in this region, the vegetation in the region, because we have the land cover, and with the ground data, we can assess what is the carbon that is stored in the trees, both above ground and below ground biomass we have assessed. It gives that about 1.23 million gigagram of the carbon is stored by the vegetation and soils in the region. See, this is this is a carbon that is emitted by the industries, industrialized countries way back, 50 years back. Now, our forests, we have only one earth. That is where the carbon emitted by them is sequestered by the trees in our forests in the Western Ghats. Now, it amounts to about 1.23 million gigagram. Every year, it takes away about 37,000 gigagram of carbon from the environment, which amounts to the carbon that is emitted by the major cities like Bangalore, Mangalore, Trivandrum, Chennai, etc. So now if you look at from the money point of view, it amounts to about 100 billion rupees or $1.4 billion. So now, what is the likely scenario? We have tried to look at it. So by 2031, it shows that by 2031, only the 10% of we will have the area under evergreen forest, only that 10%. That means there will be further degradation in this one. Now you see that using this data, how we could analyze the Western Ghats. In fact, about 20 years back or 25 years back, when I started my journey, to do the analysis of one district, people used to take 2 or 3 years. But now, today, we could do this entire Western Ghats, which is about 160,000 square kilometers, in a matter of about 4 or 5 months because of the availability of the big data, the remote sensing data, other spatial data. Now, with this kind of data analysis and visualization, you can also predict what is the likely change, the impact on the climate with the changes in the land cover or the deforestation in the region. Our prediction shows that there would be a temperature increase of about overall increase of about 0.5 degrees Celsius, and there is a changes in rainfall pattern. Some region will receive higher rainfall, some region will receive lower rainfall, and the most the worrying feature is the changes in rainy days. The rain which is supposed to come for 4 to 6 months will come in 3 or 4 days. That leads to the flooding in the region, and there will be scarcity of water with the flooding in the region. And when the flooding happens, there are mudslides, landslides happen in the region. That is what, if you have noticed yesterday and last 2 days, because of the high rainfall in Karnataka, there were 12 deaths in the Karnataka. So that shows that we need to manage the ecosystem to bring down these calamities in the region. Now, let me explain to you the linkages between the vegetation and the water. See, this gives a picture of the region in 1991 when I was a student, when I visited the region for my thesis doctoral work. So it was like this. But today, the same location when I visit, there is no water. Now, when you look at carefully this region, you see the land cover in the region probably had decided the availability of water. To understand that, I will take you to river basin and explain how this matters. So now when you look at this, you know, this is a Sharavati river basin, originates at Ambutirtha, traverses 128 kilometers, joins the ocean. Now, in this river, we constructed the dam way back in 1965. Now, when you look at this region, you see that the portion of the river basin has a good vegetation cover, while the other portion do not have the vegetation cover. It is a barren area or the degraded land. Now, when you want to understand the implication of these changes in land cover, you know what happened was there were 178 villages in this region. The villages were forcefully evicted when this dam was constructed. And those villagers who were practicing wet cultivation, they were shifted to dry area. They couldn't continue the cultivation. They waited for the reservoir work to be completed. They came to this region. They converted forest into agricultural land, and that's how the land conversion has happened in this region. Now, to understand how it has affected region, let us take up the rainfall daily data in our country. You just analyze the rainfall for the period 1901 to 1965 and 1965 to today. When you look at 1901 to 1965, this entire region receives the rainfall of 3,000 to 4,500. While now, 1965 to today, if you look at this portion where the land cover has changed, the rainfall has come down to 1,700 to 1,900 millimeter. Otherwise, it was receiving 3,000 to 4,500 millimeter. And this portion, which continues to be the good vegetation cover, as we saw in the remote sensing data, continues to get the 3,000 to 4,500 millimeter. To summarize what I said so far, this region is undulating region. It is a rain catching region. It receives the same kind of rainfall, orographic precipitation, just because of the land cover change. Say one side you have a dense forest cover, another side is a degraded landscape, you see the changes in rainfall pattern. To understand this further, let us analyze this, the forest cover and rainfall at the subbasin level. These are the subbasins on the western side. These are in the eastern side. When you look at this on the western side, the forest cover is the 30%, rainfall is 1,776. Or 31% forest cover, you have rainfall of 1,070. Compared to that, on the western side, forest cover is 65%, rainfall is 4,800. Or forest cover is 60%, rainfall is 4,400. This establishes the linkage between the forest and the rainfall. Now, to understand how long the water is available in the stream, my students monitored the select streams in for 36 months to take into the account the seasonal variability as well as the annual variability. That means year-to-year variability. Depending on that quantity of water available and duration of flow, they graded the streams as A, B, C, D. Here, the stream carry the water for 12 months. B carry the water for 8 months, C carries the water for 6 months, and D carry the water only during the monsoon or 4 months. Now, when you look at A type of stream occur in a catchment when the forests are of native species more than 60%. When we convert a forest into monoculture plantation, you have water in the stream or wells for 6 or 8 months. When you degrade the forest, or when you degrade the catchment with the forest cover less than 30%, you see the water is available only during the monsoon or 4 months. Now, let us try to understand how it affects the livelihood of the people, because we are talking about a humanitarian needs. You know, livelihood of the 65% of the agriculturists, let us try to understand through this case study. Now, when you look at this river basin, this is the region. You see that the people get 12 months of water, whereas the green is the 8 months. This is the 6 months, and this is 4 months. Now, when you look at wherever forests are dense and native species, you have 12 months water. Wherever you see that because the forest, the infiltration of the water happens to the extent of say 40 to 60%, and it also meets the demand of the society for the domestic agriculture and horticulture requirement. Wherever forests are degraded, you see it does not meet the requirement. We put the sensors in the underlying layer to understand how much water gets into the underlying layer when it rains. and how much water flows laterally during the post-monsoon. See, during the monsoon, you have water because of the rain for 4 months. During the post-monsoon, 4 months, you have the water because the water stored in this comes to the lake or river for the 4 months. That's how you have 12 months of water. Now, if you look at how it decides the livelihood of the people, the farmers in this region, if they earn 1,54,000 rupees per acre per year, the farmers in this region gets only 32,000 rupees per acre per year. That is mainly because farmers in this region can grow multiple crop or a cash crop, while the farmers in this region can grow only one crop. Then more importantly, the presence of pollinators, which are abundant and diverse in the region of where native forests are there, enhances the yield of the crop. While in this region, there are poor the pollinators. You know that for a yield of the crop, pollination has to be efficient. Now, because of the diverse and abundant pollinators, you see the yield of the crop. For example, the paddy, which is about 12 to the 14 quintal per acre per year in this region. But in this region, they can get only 8 to 6 quintal per acre. Now, as I said earlier, our country, 65% of the people practice agriculture. Now, we cannot give a job to everyone in the country. Now, to sustain their livelihood, we have to make sure that the water is available to them. So that can happen only when you have the native vegetation cover in the region. This is what we reported in the current science in the 2020. Those who are interested can download this article and read. Okay. Then the energy sector, what we have done, I'm going to share that. See, we have looked at the solar energy potential, wind energy potential, and also we have looked at what is the bioenergy potential, because we have understood how much forest cover and agricultural land is there. We know that what is the kind of bioresidues available. At the other end, we have assessed what is the demand available for the energy, bioenergy. When you take the ratio, it gives the bioenergy status. When you assess this, you will see that if the ratio is less than 1, it shows the scarcity of resources. Where the ratio more than 1, it shows that there is sufficient resources are there. That's how the planners can decide what kind of the interventions are required to meet the deficit of the resources. Similarly, we have assessed what is the biogas that is available in the region, based on the livestock residues and agriculture residues in the region. So then, which are the villages have the sufficient resources to meet the domestic energy requirement? We have computed that. Now, the similar exercise we have done for the entire country, because we have this data for the last 25 years at the NASA Reno website. Using that data and ground measurement, we have quantified what is the kind of the solar potential that is there in our country, and we map the hotspots of solar potential in our country. Based on the work of this of 2010, the country the venture into the big scale solar program. So that's where you see the solar energy has got a boost in the country. The work is based on the work what we have done at IISc. Now, my students are looking at the biofuel and the bioethanol as well as the electricity from the solar. Now, the other requirement to run your vehicle, you need the liquid fuel like a petrol or the diesel. That can be met by the macroalgae, the bioethanol, or the biodiesel from the microalgae. So this is the assessment that is going on. So for all this thing, the remote sensing data helps, because it helps in finding out where all these resources are available, how much is available, and what is the seasonal variability of these resources. Now, we have developed the decision support system, so that the planners can use the decision support system to find out what mix of energy to be used in the region for that. Now, we also have tried to develop the smart grids or the microgrids at the district level or at the village level. Based on that, we have developed the kind of the protocol for having the village as a smart village. When we talk about smart village, there is a sufficient resources are there. We are taking advantage of the development in technology to ensure that meets the requirement of the people in terms of the infrastructure or the basic communities. Now, this village concept is being implemented in one of the rural village in Karnataka, which is adopted by the local MP. Okay. Now, with that, let me bring you to the Bangalore, the city of Bangalore. This is the kind of the vegetation, the birds and butterflies that were there when I was a kid. But now, if you look at in Bangalore, I see the flooding happening, and you see that a lady is struggling to make her the livelihood by collecting the waste in the solid waste dump. So now, See, when you look at the Bangalore topography is about 740, the spatial extent is about 740 square kilometer, and topography is undulating terrain. It is like a small hillock. Taking advantage of this undulating terrain, our elders had created the interconnected lake ecosystem. You see that we had 1,452 water bodies with a 80% green cover way back in 1800 during the Kempegowda period. Now, today, if you look at, we have 193 water bodies, and the green cover is less than 8%. So that means if you look at how it has affected the temperature of the region during the May month, the summer month, the temperature in 1800 was 14 to 16 degrees Celsius. Today, the temperature is about 36 to 38 degrees Celsius. Now, another aspect, if you look at, for a few days in December, the temperature was 0 degrees Celsius. And we were growing apples in a place called Palace Orchard, closer to the IIC. But of course, today we don't see the palace in the Palace Orchard, the apple, but we see a lot of waste being littered in the city. Now, as I said earlier, our lakes are interconnected. Now, if you look at the remote sensing data, interconnectivity among the lakes have lost. Because of that, there is the water scarcity in the region, and more importantly, flooding happens in the region. See, earlier, our elders had created the water bodies to meet the city's requirement or the town's requirement. For example, if you see this is the fort of the earlier Bangalore, and adjacent to that, in the current KR market area, we had a lake in the region. So, and of course, today, people think about the lake view apartment when they see the lake. Okay. Now, let us see how the changes have happened in the region from 1973 to 2019. If you look at 1973 in a Bangalore landscape, we had a 68% green cover. That's why the Bangalore was known as a garden city or the green city. And blue is the water body, red is the building, and yellow is the open space. 92, you see with the industries coming up in Pini and Koramangala, the changes started happening. In 2000, we saw the IT-BT sector coming in the outskirts. Changes have started happening. Then 2006, you say the intensification. 2009, further intensification happened. Now, if you look at this, the 2019, you have that about 81% of the Bangalore landscape is concretized. You see only the building and a fewer the greeneries in the region. Now, if this trend continues, what is going to happen in 2025, we have visualized, and we notice that 98.5% of the Bangalore landscape would be concretized. That means over the last the 4.5 decades, there has been 1,055% increase in concrete area, and we have lost 88% vegetation and 79% of the water body. That's where I am insisting the government to decongest the city. But you know that what kind of the people we elect, such irresponsible people, we don't see the proper planning happening in the region. Now let us try to understand how many trees are there in Bangalore. Again, remote sensing data helps. This is my campus, Indian Institute of Science campus. Using GPS, we map the trees. Link that with the remote sensing data. This helps us the ground data, the training data. Similar exercise we did in a couple of wards. Then using remote sensing data for the entire Bangalore, we mapped how many trees are there. So our study shows that there is 1.5 million trees are there for a population of 9.5 million. That means for every 7 person, 1 tree is there. But if you ask how many trees are required for each person, we need 7 to 8 trees, because we all breathe. When we breathe, we got carbon dioxide to an extent of 980 grams per person per day if you are young, and if you are an elderly person, then it is 540 grams per person per day. Then 1 hectare of tree takes away the carbon to an extent of 6 to 8 tons per year. So that means by that ratio, 1 tree, for every person, there should have been 7 to 8 trees. That means what we see is a degradation in the city. Now, to understand the linkage between the tree and the temperature, we use the thermal data. You see what was 19 degrees in 91 has become the 21 degrees or the 26 degrees in 2010. Now, from the city center, we have moved in 8 direction to understand the temperature profile of the city. You see that wherever lakes are there, all the vegetation is there. Temperature is 2 degrees. Entities are the ecosystem like water bodies, or the vegetation helps in mitigating the temperature or lowering the temperature. That's how it moderates the microclimate in the region. Now, let us try to understand the importance of the lake. See, when the lakes are not polluted, we see that we get the people get fish, fodder, agriculture product, etc. to an extent of 10,500 rupees per day per hectare. When we pollute the lake, you see that the worth of the lake come down to 20 rupees per day per hectare. Now, with the unplanned urbanization, we have lost 79% of the lakes in the city. The red ones are the one we have lost in the thing. And apart from that, lakes have become seasonal. There is a groundwater table at decline, and then changes in local temperature has happened, as I said earlier. Now, if you look at groundwater table decline, when the lakes were there, people were having the water at 80 to 100 feet. Today, after removal of the lake in 5 years, it went down to 600 feet. Today, people have gone down to 1,900 feet in a place like Nakshattihalli, but they do not have water. That is the kind of situation we have created. Okay. So now, let's try to understand further. As I said earlier, lakes gives us the goods in the form of fish, water, washing, cloth, agriculture, etc. We have done this analysis for the entire Karnataka to quantify the provisioning, regulating, and cultural services. See, cultural services mean the recreation benefit. Regulating services include the carbon sequestration, groundwater recharge, etc. So now, when we do that, you see that the inland wetland, that means the lakes, has the worth of about 10 lakh rupees per hectare per year. Now, if you want to quantify that for the entire Karnataka, what we have done, the worth comes down to the per year, it comes to about 240 million rupees or $1 billion per year. If you want to see the worth of the lake, it amounts to about 7,320 billion rupees. That is the net present value of the lakes in Karnataka. Now, the similar exercise we did for the entire Karnataka. I'm just demonstrating the power of the big data, the spatial data, what we have. So now, what was the land cover in 1985, 2005, and 2019 we have predicted. We have collected the training data using the GPS, which was used with the remote sensing data to do the classification. If you look at Karnataka, what is evergreen forest, 7.54% has come down to 5.68% in 2019. Not only forest, that's what it shows. The intact forest, which is 16% in 1985, has come down to 5.9%. Now, the consequence of that is the increase in the temperature. That's what we see that as we move from 2006 to 2018. Now, we have also done the valuation of the goods of the forest. You see that we have looked at the quantity of the resources available, what is the price of that, and what is the cost. We have deducted that. That is called residual value. So similarly, we have done the regulating and cultural services quantification. Now, this gives the provisioning, regulating, and cultural services forest ecosystem is 2008-94 in 2005 has come down to 1,835 billion rupees per year in 2019. See, that's how when you degrade the forest, the kind of the goods what we get from the forest also get declined. So we degrade the forest to an extent of 40 to 45%, and you see the ecosystem services are declined by 35%. Now, as you all know, the country always uses the GDP. We are trying to push the government to see degradation cost when we compute the GDP. So that's what we are looking forward. For that, we have done the analysis for the Karnataka state. Now, with this, let me come to the concluding part of my talk, how we have been doing the society relevant science for humanitarian needs. I've been working for the last 2.5 decades. The science what I have done in my lab, I have taken to the society also, and people have benefited because of this science. So now, what are the things we have done? Wastewater treatment with a constructive wetland and algal pond, then rainwater harvesting through the lakes and rooftop harvesting, then creating a mini forest, which I have demonstrated how much carbon can be stored and what is the groundwater level changes that happen with mini forest, and also improvement in oxygen. So then apart from that, recreation and other things. Then another important thing what I do is like today what I'm doing is sensitizing the youth, equipping them with the environmental knowledge. When you look at the environmental literacy in the places like Bangalore, we saw that only 3.5% of Bangaloreans know about the issues or environmental the aspect. But that means 96% of people do not know from where they get water, how do we get electricity, etc., or how to manage the solid waste. Because of that, 96% of the people who are irresponsible, we have the problem in the city like solid waste littering, liquid waste mismanagement, etc. Now, see, this is the shows the glimpse of our program, what I have been doing from 98, the popularly known as Know Your Ecosystem. We interact with we have conduct the orientation program for the school children. Then we also conduct a course on environmental management and municipal solid waste. I have done for the last 19 years. Now the 20th session we have announced. That means this is for the people working in industries as well as the universities and institutions. That's how we are doing capacity building at all levels to improve the environmental literacy in the region. Then, say, I conduct a program known as a Lake Symposium once in 2 years. So I've been doing from 98. I have conducted 12 events. The uniqueness of the event is, though it's an international event, I also give a platform for the school and college students. When the school and college students capacity building happens, not only they take part, they also do the presentation of their experiments on the concluding day. That's how we do the capacity building. Children do the simple experiment like catchment mapping or the water quality assessment. They have been trained here. They collect the water the samples from the lake. They come to the lab, analyze it. The people in the children from the rural area, they do the neighborhood mapping to find out what kind of plants and animals are there in the region. What is the medicinal value of those plants? You can see here the kids are monitoring the trees to assess the carbon that is stored in the trees. Then the wastewater treatment based on the nature principles. So you see that the wastewater consists of the chemical ion and the nutrients. So that to treat that wastewater, you need to remove the chemical ion and nutrient. There are 3 levels of treatment: primary treatment, secondary treatment, or tertiary treatment. Primary treatment will remove the large particle. Secondary treatment will remove the chemical ions. Tertiary treatment will remove the nutrient. When you generate a sewage at home, you are generating the wastewater which contains the chemical ion as well as nutrient. That means we need to do the tertiary treatment. But what municipality does is they will put only secondary treatment plant. So that means when you do the secondary treatment plant, you are not removing the nutrient. So what I did is I just integrated the constructed wetland and algal pond along with this. That removes the nutrient to an extent of 85 to 90%. Now, for your information, this was done at Chikor way back in 2010. For the last 10 years, we have monitored. My students have monitored the thing, and this report is available online. See, way back my study in this region, 2005, shows that lake as well as surrounding bore wells or wells had the nitrate. Nitrate is a carcinogen which introduces cancer. But by integrating this technology, there is no nitrate either in the wells or in the lake. Today, there are 300 wells in the locality. None of the wells have nitrate. That means I am giving the water at least to the 300 plus family, the well users, they clean water without any contaminants. So this is the model I'm trying to see that we can replicate in many parts of the country or in the globe. Then to summarize what I said, the rainwater harvest about 18 TMC of water. If you look at the rain, we get about 700 to 850 millimeter of rainfall. That means we get about 15 TMC of water. So, and if you are using 18 TMC of water, you are also generating 18 TMC of wastewater. If you treat it something similar to the Jaipur model, then you have 16 TMC of water. That means 15 plus 16 TMC, you have 31 TMC of water, which is surplus situation. That means everyone will have adequate water. But for this to happen, we need to, I have a 5R formula. The first R is a responsible citizen. When people are responsible, they will rejuvenate the lake, they'll retain the rainwater, and also they will treat the wastewater. That's how we will have the surplus situation. You know, now for your information, the Belandur and Vartur Lake is being National Green Tribunal of the Supreme Court. Okay. Now, if you come to ISC, I have created a lake in the campus, you know, way back in 2008, which stores 10 lakh liters of water. Now, this has become a lab for my student to do the biofuel study. Not only the students are happy, we also have water. As you all know, the water requires a lot of fish. Otherwise, it won't survive. I do not go and feed the fish, but nature has provided the fish. When we did the documentation of biodiversity, we see that algae, zooplankton, and the fish, once we facilitate the region with the appropriate environment, nature will provide the food for everyone. Now, when you look at this model, see, I stay on the campus. My family requires 500 liters of water. That means per year, I require 1.5 lakh liters of water. But what I am storing is at least 10 times higher than that. That means when you give back to the nature 10 times of what you are consuming, there won't be the resource scarcity poverty in the region. And when I made people to create the lake. This is what happened in Modubidre, where in the region where the people faced the water crisis in 2014 and 15. When they met me in 2016, 15 days. The success is because of the youth. Alva Science and Technology, the institution, have taken part in this initiative. When I see the CEO is also quite young. This demonstrates if we equip the youth with the appropriate knowledge, we can transform the world. So that's what we have been doing. Now, this gentleman is quite young. So we made sure in his campus, he create the water body in the next year, which stores 25 lakh liters of water. And also he took up the plantation of the native species. When I visit this region and this institution quite often, as a guest faculty. So 2018, when I visited, you see that the greenery with abundant water. See, when the resources are plenty, you will see the prosperity and the resource, the surplus situation happens in the region. Now, if you come to the campus, the other thing is you will see this climber in front of our building near ACRC. So I was fascinated by this architecture when I was saying. So I felt that I should have in the campus that in Bangalore, in my campus, that's where I brought the seats. This is the pot which had 14 seats. Out of the 14 seats, 7 seats were planted in the 7 location. Out of the 7 seats, only in 1 location it has come up. That is next to this building where I've been working for the last 25 years. So that means even the plants know who will take care. Now, in front of this building, we created a mini forest in a 2 hectares area. 49 native species, about 500 saplings were planted in a 2 hectares area. At that time, in 90s, when I was a student, this region was infested with Parthenium and groundwater table is 150 feet. Today, I have the water at 10 feet, which demonstrates that there is a linkage between the vegetation and the water. That's where we need to manage the landscape to sustain the water in the region. Not only that we got the water for the human, number of snakes, reptiles in the region, and also we have 4 families of the slender lories or a cardpapa in the region. Okay. So my talks are available in YouTube. You can do the Google search, YouTube, TV Ramchandra, you'll get it. And for your information, I have created the water testing labs in some of the rural schools which were not able to have their own water testing lab. So my vision is that when I give the knowledge of water quality to the kids, they will never pollute the water nor abuse the Mother Earth. So now my publications, the data is available at this portal related to biodiversity. And I use the free and open source software for spatial analysis that's available at this portal, including content management systems. And my research papers are available in this archives. So when you access my webpage, it looks like this. All our publications are available online. The PDF versions are there. You are most welcome to download and you can go through that. If you have any doubt, you can write back to me at this email ID. When I look at the country, we have 65% youth. We have abundant solar energy, so which gives us the electricity and hot water for bathing. And we have the biofuel prospect through the algae from the water bodies. If we harvest all these things, our country will become a developed country and everyone will be prosperous in our country. That's what we are looking for. That's where our science is striving for, to make everyone happy. I don't want only 10% of the population being rich and corrupt. I want the entire system to be honest and have the abundant resources in our country. So this can happen only when we do the good science, and that science reaches the destination. And our youngsters, who do this science are here. When they do a good science, there is a smile on everybody's face. Thank you very much. Dr. Anandi, I have completed my talk.
Thank you so much, sir. Thank you for such an insightful talk and your contributions to this humanitarian technology. And our IEEE site team will be very much interested to collaborate and learn, especially on the renew, recycle, and reuse of water bodies. And thank you for your time in spite of your busy schedule. Thank you so much, sir. Any questions from the audience, please? Okay, so any doubts, you can always email him as he has given his email ID. So thank you again. Let us give a big round of applause.
Okay, thank you very much. My only advice to all the kids is respect Mother Nature. Respect your mother at home. When you do that, you will also respect Mother Earth. When you respect Mother Earth, there won't be solid waste problem or a liquid waste problem in our city or in our villages. We can make our country proud. Thank you all for listening. I hope, even though the audience is a small number, I am sure they all would have understood and disseminate this knowledge in the wider section of society through the social network or any other mode, so that they can join with me in making more and more people environmentally literate. Thank you all. Thank you, Dr. Anandi, for giving me an opportunity to share the platform with the youngsters.
Yes.
Okay.
Thank you. As token of appreciation, the memento will be sent across to you, sir, because it's a virtual thing. I'll meet you in your department.
Thank you. Thank
Yes,
you.
thank you. Yes.
Sure.
Thank you.
Okay. Anyway, I am also organizing a symposium, the Lake Symposium, scheduled in December. So your students and volunteers are most welcome to take part. They can learn and they can become so that it gives an opportunity for them to become a responsible citizen in our country, or they can even become a global citizen also, responsible global citizens. Okay.
Thank you so much.
Thank you.